My name is John Waller. I'm the Risk Advisory Practice Lead at UV Cyber, and we're going to be moving beyond the high-level checklist to discuss a fundamental shift in AI governance, and that is an architecture-aware approach for embedding governments directly into the AI systems that we build and deploy. And our goal today is to show you how to treat governance not as a restrictive compliance obligation, but as an engineering capability that actually allows you to deploy AI more confidently and at a greater scale. And before we continue, I want to acknowledge that we have used AI to assist in the preparation of this presentation, and in particular, Google's Notebook LM for slide creation. Next slide, please. So let's start with a few statistics. As organizations accelerate AI adoption, governance maturity is not kept pace. For example, 85% of enterprises intend to become agentic within 3 years, yet 76% acknowledge their operations can't currently support it. 75% of organizations have established AI usage policies, but only 36% have adopted a formal governance framework. And participants to this webinar, everybody here on the call, you were asked, what's your biggest blind spot when it comes to securing enterprise AI? And visibility into AI risk was number one with 51%, lack of expertise at 18%, tooling gap 16%, and fragmented ownership at 16% as well. These are all topics that we're going to cover today. So the hard truth is that 95% of all AI projects fail to deliver bottom line value when they move from the sandbox into production. This isn't because we lack policies. It's often due to one or a number of the issues that we're about to discuss. And it turns out many organizations have prioritized development velocity over operational discipline, leading to a massive gap in controls being identified and deployed. Ayush? Yeah, next slide, please. There we go. Thank you.
Next slide. I think John covered this part.
Not the treating AI like traditional software.
Yes. So, yeah, thanks, John, for the high-level overview about it. Yeah, most of the things that we have been seeing in the industry today is like the operational challenges the organizations are facing today is they are treating it as the traditional software, right? What we are seeing across the industries is that the traditional control mechanism we relied on for the software system simply do not translate well into the AI environments. As John highlighted, the operational reality of the AI system introduces new dynamics of the non-deterministic outputs, rapid model integration, data dependency across pipelines, and increasing autonomy in the agentic systems. So the traditional governance models was designed for the predictable software systems, but the AI systems behave more like the adaptive systems. So the question becomes, how do we translate the governance principles into something that we can actually operate within the AI system architecture? And that is where the idea of the AI governance by design comes in. Many times, the performance is often mistaken for the controls in the AI system. And that is where we are treating it as the governance as the main model where we keep everything in track and then make it working. Next slide. Yeah, so the main thing over here is like, sorry, give me 1 second. Yep. So, sorry. So the accuracy does not equal to the safety. That is what we have been like treating mostly in the traditional software security. A model may achieve a very high accuracy on the validation data set, but still produce harmful, biased, or unsafe outputs in the real world scenarios. Second is the metrics. Metrics are designed to optimize the performance, not the governance. Metrics does not measure whether the system behave ethically or within the policy boundaries. And third, AI systems drift over time. Data environment changes, user behavior evolves, and model performance gradually shifts. The model is the traditional performance. Dashboard often remains green while the risk is like quietly increasing on the behind. So the high-performing AI systems are not necessarily well-governed AI systems. Next slide. Right. So many organizations fall into what we call as the architecture blindness. They attempt to apply the same governance checklist across very different AI systems, whether it's a custom ML, a foundational model chatbot, or the agentic systems. But the reality is that each architecture has different risk surfaces. When governance does not account for the architectural differences, it leads to two outcomes. Either governance becomes overly restrictive, slowing innovation, or dangerously incomplete, leaving critical risks unaddressed. Next slide. So another issue that we are seeing is like governance without the evidence. Many AI governance rely on the retroactive documentations, but the real governance requires operational evidence, things like logs, runtime telemetry, and then the system traces. Next slide. To move beyond the problem we just discussed about the existing things that we are seeing in the industry, we need a structures on how the AI governance is implemented. First and foremost is alignment. Governance control must align with the architecture and risk profile of the AI systems. Second is the consistency. Without a structured approach, a governance becomes fragmented, where different teams apply controls differently, and the structure framework ensures that the controls are applied systematically and more predictably. And third is going to be the scalability. AI is evolving, it is always evolving, it is growing every time. So the AI adoption is accelerating. Governance cannot rely on the manual reviews and ad hoc processes. It needs to scale as organization deploys dozens or even hundreds of the AI systems. Next slide. Now, the good news is that the framework landscape is beginning to converge. Standards like the NIST AI RMF, ISO 42001, and the CSA AI controls are starting to align around like common principles like the accountability, transparency, risk management, and monitoring. But there is still a gap. These frameworks provide guidance and principles, but they often stop short of explaining how governance should be implemented inside the real AI systems. In other words, they tell us what good governance model looks like, but not how to operationalize it within architecture and engineering workflows. So the next slide that John will be taking over will be about the flow that we already have. So John, passing to you.
Okay, great. And then, as Ayush mentioned, basically what we're going to be talking about is how we can apply these domains that have been outlined by the Cloud Security Alliance's AI framework, and we're going to use that as our backbone. And I had the privilege of being able to consult or provide some commentary on CSA's Trusted AI Security professional program. So that's sort of where I gained the experience about the 5-domain backbone. So we're talking about these domains: accountability, data governance, model risk, security and resilience, transparency and monitoring. These domains, they remain constant throughout, but how you implement them shifts, often significantly, depending on whether you're deploying a custom model, an integrated foundation model, or an autonomous agent. So what we'd like to do is basically walk through how you apply these 5 domains across those 3 primary AI systems. Next, please. So our custom AI systems, the first model, these are the models where you maintain the full lifecycle ownership from data ingestion to retirement. As I mentioned earlier, but it bears repeating that 75% of organizations have AI policies, but only 36% have a formal framework for these custom builds. And in this model, your primary risk surface is the training data and its lineage, because the model's behavior is directly shaped by the corpus that you provide. Next, please. Again, we had 5 domains. The first domain is accountability. In custom AI environments, accountability must be tightly coupled to the entire model lifecycle, extending far beyond simple application functionality, like we've seen with software security. And a primary architectural requirement is the strict separation of model development roles from risk approval authority. This ensures that the organization maintains objective oversight and owns the risk. Owns the risk from end to end. And additionally, retraining must be governed as a critical stage event rather than a routine code push, because retraining can quietly and significantly alter a model's probabilistic behavior. It requires explicit reevaluation and human intervention to prevent the introduction of explicit risks without oversight. Next, please. Yeah, I'm sorry. Data governance, back to that one. Thank you. The second pillar is data governance. And custom AI systems carry the highest data governance burden because the training corpus directly shapes the resulting model's behavior. This necessitates that provenance, licensing, and representational balance are strictly validated before any training begins. Equally important is the forensic capability of lineage, which allows the organization to reconstruct exactly which approved dataset influenced a specific model version. And ultimately, the data governance in this context is not a static document, but a continuous discipline embedded in the pipeline to ensure that the data is never repurposed without an appropriate review. Model risk and security, number 3. Model risk in custom environment requires validation that goes beyond accuracy to include bias assessments, stress testing under edge case conditions. From a security standpoint, your training pipelines are high-value targets and must be isolated, effectively air-gapped, to prevent unauthorized data poisoning or parameter tampering. We must also validate the entire supply chain of third-party libraries used within the machine learning workflow. And finally, transparency. Transparency is the ability to replay the build. This requires a rigorous model registry that provides version control for both the data and the model artifacts. If you cannot recreate the model from your registry, it's effectively ungoverned. And we must track every parameter change and validation outcome so that every decision the model makes can be traced back to specific training conditions. Ayush?
Yep. So thanks, John, for covering that part. So while the custom AI system allow governance to be embedded in the training and then the development lifecycle, the foundation model system's completely different. And that is the main idea about like why the systems has to be treated differently. So in most cases, organizations do not control the training process of these models. Instead, they consume it through the APIs or through the managed platforms. This means governance must shift from the model development control to the interaction controls. This is where the concept of the governance gateway becomes more critical. This gateway acts as a control layer between the user and then the foundational model, enforcing the policies around the prompt validation, like data protecting or the output filtering or any of the users monitoring. So rather than governing the model itself, we should govern how the model is accessed and used. This architectural gateway becomes primary enforcement point for the governance in the foundational model systems. Next slide. So foundation AI introduces a shared responsibility model. This model provider is responsible for aspects like the model training, like baseline safety and the infrastructure. But the enterprise remains accountable for the model, how the model is used within its environment. This means accountability does not disappear, but it does shift. Just like in the cloud platforms that we see, which are the big buzz, like when it first got introduced, there is a shared responsibility, same like for the agentic AIs or any of the foundational things. It translates to the same thing. So the enterprise must take the ownership of how the prompt are structured, or how data is sent to the model, and how outputs are consumed and acted upon. This is where the guardrails authority becomes critical. We must enforce controls at the interaction layer, ensuring that model uses stays within the defined policy boundaries. So even though the model, last part on that, but forget. Yeah, even though the model is external, accountability remains still internal, which is driven by how the system is architectured and governed. Next slide. So in the foundation model system, the most critical point for data governance is the integration boundary. you'll be hearing me talking about the integration mostly on this model, but like that is the main meat of it. So this is the point where enterprise data interacts with external model, typically through the APIs or through the gateways. Since we don't control the model itself, this boundary becomes the primary enforcement point for data protection. The goal is to ensure that no sensitive or regulated data is exposed unintentionally. And this is where the organization manages risks like the data leakage or the unintended data retention, misuse, or any of those things. So governance is about controlling what goes to the model, because once the data crosses the boundary, we have a very limited control on that data. Next slide. So the model risk management in foundation AI system looks different from the custom models because we typically do not have the visibility into how the model was trained. So the traditional model validation approaches are limited. Instead, our risk management shift to how model behaves in the real world users. This includes the evaluating risks such as the hallucinated or the incorrect outputs, biased responses, or even the inconsistent behavior across the similar inputs. To manage this, we must implement validation layers such as the output checks, the rule-based filters, or human-in-the-loop mechanism. So most importantly, model risks must be continuously monitored in context because performance can vary depending on how the model is used within the system. So again, governance is enforced not inside the model, but around it for the behavior and the users. Next slide. So in the foundation model, security shifts to the interaction layer because since we don't control the model internals, the primary risks come to how the model is accessed and used. And this introduces a new kind of the threat, such as the prompt injections or the sensitive data leakage or misuse or the abuse of the model. To address this, we must enforce the guardrails at the input and then the output level, including the filtering, validation, or the policy enforcement. Additionally, API security and access control becomes critical to prevent unauthorized or the excessive users at this point. Resilience is going to be equally important because the system should be designed to fail safely with failback mechanism. So system security and resilience in the foundation model are about ensuring that even if this model behaves abnormally, like unpredictably, system remains controlled and data are protected. So the last part on the model is about the transparency and monitoring. So in the foundation model, again, the transparency is not about understanding the model internals, but it's about observing how the model behaves in the real time. This requires strong visibility at the interaction layer because we must be capturing the prompt sent to the model, responses generated, and then the action taken down by the downstream systems. This creates a traceable record behavior, and then the real-time telemetry becomes more critical here. As we discussed earlier, I think I mentioned that earlier, governance without the evidence cannot be trusted, and telemetry is that evidence. Monitoring also enables detection of the misuse of the abuses. Ultimately, a transparency and the monitoring ensures that the AI systems are not operating as black box, but as visible and auditable systems. John?
Yeah, so we move on to agentic AI and the autonomous zone where AI agents perform actions on our behalf. In agentic systems, AI transitions from an advisor to an operational actor. And as a reminder from earlier, fully 85% of enterprises intend to become agentic within 3 years, yet 76% acknowledge their operations cannot currently support it. This means that this fastest growing segment of AI use needs governance principles, and fast. In agentic AI, accountability is really at the action level authority. We must define which actions require explicit human permission and set escalation thresholds. Most importantly, every agent needs a kill switch capability, a hard stop that allows us to instantly sever the agent's connection to external tools if its behavior deviates from safe norms. Agentic data governance is unique because agents use persistent memory. They retain context across multiple steps, which creates a risk of context leakage. Therefore, we must enforce context containment to ensure that data accessed from one task isn't inappropriately used for another. And we need to set strict cross-system boundaries to prevent the agent from silently expanding its knowledge scope beyond what its current task requires. And again, completely different from custom and foundational model. The risk management here, it's in this autonomous environment, a hallucination could lead to an incorrect action, not just a wrong word. So risk management here requires multi-step scenario simulations. We must perform toolchain red teaming to find vulnerabilities that only emerge when an agent uses multiple tools in sequence. And we focus on execution safety. We're ensuring that the agent only follows validated paths and that high impact actions require staged execution or explicit confirmation. And to ensure that an agent, to secure the agent, we use the sandboxed execution environment. And the agent acts within an engineered conduit, if you will, made of controls that limit its reach. We enforce least privilege, giving the agent only the narrowest possible permissions that it needs. And every external tool is on a strict allow list, ensuring the agent can't reach into unauthorized systems, even if its reasoning fails. And finally, monitoring agents means logging the intermediate reasoning, the thoughts that occur between the prompt and the action. And we must record the full action chain, including tool calls, execution outcomes. With active supervision, we use real-time detection to catch runaway loops or deviations. And if an agent takes an unauthorized step, our logs must show exactly which reasoning led to that decision. And now I'd like to turn it over to Ayush. Basically, we talked about three verticals, and Ayush will talk about the sort of horizontal layer that will make them all work together.
Yep. So as we move away from this like three dimensions that we just talked about, right now we need to talk about the system level governance. And one thing becomes clear, that is the ceiling of acceptable risks is set at the top of the organization. First, organizations must define their risk appetite. What level of AI risk is acceptable across the use cases? Second, this cannot be driven bottom up. It requires the executive sponsorship. Without the leadership alignment, governance becomes inconsistent and often ignored in the practice. And third, governance must have the strategic legitimacy. It cannot be seen as a compliance burden. It must be recognized as a business critical functions that enable safe AI adoption. Ultimately, the business's risk tolerance directly influences on the AI systems designed, controlled, and deployed. Next slide. So this is going to be interesting because with even with the strong architecture and controls governance, ultimately everything depends upon the human layer. So the different role across the organization interact with the AI systems in different ways, and each requires appropriate AI literacy. For example, engineers need to understand the system behavior risk. Business users must know how to use AI responsibly, and the leaders must understand risk implications and then the governance priorities. AI systems are not fully autonomous. Even well-designed governance frameworks can fail in practice. So governance is not just technical, it is also organizational and behavioral. Next slide. Yeah, and one of the biggest challenges today is the shadow ID. AI tools being used without formal approval or oversight. Employees are already using AI for productivity, often outside the governed systems. This risk is not just users, but it is the lack of the visibility. You cannot govern what you cannot see. So the first step is discovery, understanding where and how AI is being used across the organization. But governance is not about shutting the things down. It is about enabling the safe and approved alternatives so users don't need to go outside. The goal is to bring AI users into light, where it can be properly governed, monitored, and secure. Next slide. So as the AI system evolves, we must look into it from the data loss prevention that we have been using. So the traditional DLP focuses on the structural channels like the emails or the file transfers. But with the AI, data now flows through the prompts, responses, and then the interactions. This creates new risk. Sensitive data can be unintentionally exposed or spread to the AI system. So DLP must become AI aligned. This means enforcing controls in the interaction layer, including detecting the sensitive data in prompts, filtering the outputs before they reach the users. And the most important thing about all this thing is it has to happen in the real time. AI-aligned DLP is not just a security capability, but is a core governance enforcement mechanism. Throughout the sessions, John and I have been talking about like the governance needing the control, the evidence, the enforcement, and all those things. DLP can be one of the factors where all three can come together because it enforces the policies and generates the evidence through the logs, alerts, telemetry, proving that governance controls are actually working.
Awesome.
Mhm.
Yep. And then just thinking about governance, it's not a static gate, it's an active defense. And continuous assurance is only valid through constant red teaming and adversarial simulation. We use drift detection to monitor the silent decay of our models over time. And this adaptive approach ensures our controls evolve as fast as AI itself. And just wrapping up, it's really everything that we've been talking about. Next slide, please. Everything that we've been talking about, if you think about it from the top down, the organizations that win with AI won't be the ones with the most advanced models. They're going to be the ones that can deploy them safely, adapt them continuously, and defend them under scrutiny. An architecture where governance is how capability is built, and in a landscape where AI is moving faster than the frameworks designed to contain it, building it into the AI lifecycle is not caution, it's going to wind up being a competitive advantage.